So glad to be here. And today I would like to share about our current work. It's named Mobi, a mobile-based light client. I'm Suen Han and partner of the ABC Labs. So ABC is not just a venture capital. We are always make our hand dirty before we make the investment. So that's a part of the investment strategy. So this work is powered by the ABC and SEA. SEA is another company which are doing really good job on ZK hardware acceleration. They will help us to build a more efficient stateless light client. So the entire blockchain community is founded on one core principle. Don't trust, verify. This principle serves as a foundation pillar for the architecture of the blockchain networks. So after the PoS, so the Ethereum officially posted their light client works, but fortunately, several third-party teams are initiating their own implementations, such as Nimbus, based on NIM, and Lodestar, based on the TypeScript, and Helios, based on the Rust. So however, none of the light client solutions can natively run on the most ubiquitous devices, the mobile phone, right? And so our goal is quite simple. We are working on to offer to Ethereum community alternative. A light client can run on any mobile devices. So the motivation. So why this is technically feasible? So as 2024, the performance of the edge devices has advanced significantly. We are already seeing some developers running local LM on your mobiles. And running a light client on the mobiles only require a periodically network communication and some storage. So therefore, running an Ethereum light client on the mobile is entirely feasible. So how to make it happen? So our goal is not build something new, and we want to build a SDK for the native running light client for the mobile platform, especially for the Androids. So we don't want to build something already happened. So the whole architecture is based on the very efficient library called Helios, created by XSD. And Helios is based on Rust, and what we are doing here is to make a Kotlin wrap and to make it as a library for the Android. So our secondary goal is after achieving the compatible with the Ethereum mainnet, and is to make a hub function to offer light client services for all Ethereum layer 2s if they provided light client protocol. And so because their time is limited, and we'll share some experience to make it happen. So as we know, the Helios is code base written in the Rust. So they're containing a significant amount of their synchronized thread. But Android is on that hand is built on their Kotlin and with running on the JVM. So the Rust do not have their garbage collection mechanisms, whereas their JVM has the GC. So this happened a lot of times that results in the synchronized thread has been incorrectly garbage collected by the JVM. So it's really painful. And moreover, Android, you have some unique permission protection mechanisms, including the various permission across the arrows when directly involve some Helios code base. And eventually, we have some long ambitions. So apart from the basic functionality, we have further expectation for the mobile light client, including but not limited to the following two directions. The first one is functionality. The core function of the light client is verification, right? But however, given the storage performance of the modern devices, we aim to build something called Light Client Plus. So beyond the simple verification, we intended to add some storage compatibility. For example, users could selectively store some state and historical data of themselves, and then they can query them locally. And additionally, we want to build some RPCs functionality for other light client nodes. It's kind of the portal network. And another part is the entertainment, or make it more smart. As we mentioned, so in addition to the light client, the mobile devices now have the ability to run local LLM inference. So for example, Android private local Gemini inference APIs. And we want to explore where we can combine the local node and the local LLM together to conduct something interesting. And so here is a demo, and I bring my phone here, but due to the time limitation, if you got interesting, I can show you after this talk. And another demo is called local RM, and I bring the Llama 3 billion to the phones, and I can show them after the talk. So that's all. And about myself, I'm partner of the VC Labs and final year PhD at QST, and my interest about the database and VC Labs. So thank you.
All right, thank you, Suyao. Do we have questions for our friend, amazing speaker here? Okay.
Hi there, thank you. This is great that you're working on like clients in the ecosystem.
Yeah.
How long does it take for the client to be connected to the network? And then how quick can you, for example, do an ETH call and validate that if you build a mobile application on top? And how secure is that at the end? Maybe you can talk to that.
So actually, the Ethereum protocol provided a native function called getProof. And you can use the getProof to verify the data from the other client. So the Helios, basically the Helios work that you can verify any data from untrusted RPCs in a local way because the protocol cannot be changed. So that's really how to guarantee the security.
Yeah, no, I understand that I'm in the same boat as you, but if you do an ETH call, right, which you want to do a method call,
yeah.
You don't know if the VM that is on the remote side is executing correctly. So do you have a local VM, or like how do you solve that problem?
I think the light client do not have the local VM. They just use their getProof to verify the correctness of their Merkle tree.
Yeah, but with the getProof, you can only prove the storage, not the result of a call.
Yes, yes. Oh, that part is that we want to introduce the AI agent part, like to use LLM to detect whether the core is malicious or not, to help. Because actually the functionality of the light client is very limited so far. So we want to extend something new. That's what this mentioned. Yeah.
Next question.
Okay, so since you are working on mobile, right? There's another constraint which is power.
Yeah.
So how's the power consumption on phones running on yours?
You mean
the battery life? Like how?
Oh.
Did you optimize for it? Or
so actually, we are working on a benchmark, like how many EVM calls can call on current mobile devices. Yeah.
Okay.
A follow-up to the previous question about how ETH call works. So the way how it works is you have a local EVM inside Helios. They use the Reth EVM, Revem, and it uses ETH getProof to fetch the code.
Yes.
You can get the code from the state tree,
yes.
put it in, and whenever the EVM needs some storage that it doesn't have available locally, it is another ETH getProof. Like it's a lot of round trips, there is a lot of latency, there are some efforts on the way to improve that, like to make it more compact. But because the Revem runs locally, it means that you can trust the local execution. And later on, if you have seen yesterday's talk from Justin Drake with like the redacted title, in the future, once we have CK snarks that prove the execution, and the server can also do that, and we don't need the local EVM.
Guys, thank you so much. We'll continue this conversation. Meet Suyao backstage and